Hi class, good day everyone. Today we're moving on to chapter 5, which is the thermodynamic cycles. Okay, so this lecture of thermodynamic cycles is exclusively for my industrial engineering and geological engineering students. Okay, so this lecture, okay, these are all from, not all, but are from our module also. But this one is a summarized version po. Alright, so don't worry, I'll be uploading this lecture sa ating pong Google Classroom. Alright, so thermodynamic cycles. Okay, still po, this will be part of the coverage of our final exam. Okay, so introducing to you thermodynamic cycles. Okay, so thermodynamic cycles are fundamental to understanding how how energy systems work. Okay, converting heat into useful work or vice versa. Okay, so as future engineers, you will encounter these cycles in designing, optimizing, or even analyzing systems that power industries, extract resources, or improve efficiency. So, based on the researches or based from the researches I have done, okay, so here is what I found. For my industrial engineering students, okay, here are the relevant or here's how thermodynamic cycles are relevant to your field. So for industrial, again, for industrial engineering students, uh, first thing first nakita ko dun is about sa manufacturing systems. Okay? Sabi doon, efficient energy use in machinery like compressors, turbines, and refrigeration system. Second, nakita ko dun yung about sa power generation. So, about optimizing engines, power plants, and energy system to reduce waste and increase productivity. And this one, I think somehow familiar kayo dito. Process engineering. Okay, so in designing heating, cooling, or mechanical work systems for industrial applications. So yun yung relationship or I would say application ni thermodynamic cycles for industrial engineers. Okay, and then for our future geological engineers. Okay, so thermodynamic cycles relate to yung geothermal energy extraction. So understanding the Carnot cycle, which will be discussed later on, will help you design system that utilize Earth's heat efficiency. Okay, so it is also related to the mining operation. Diesel engines, which hindi na natin isasama sa discussion natin, but still, diesel engines po operating on diesel cycles, power heavy machinery. Knowledge of cycles will help you ensure po reliability and efficiency. And lastly, okay, thermodynamic process, okay, heating and pressurizing or cooling system in drilling and refining operations. Okay, so ayun po yung ating I would say relationship or the application of thermodynamic cycles sa bawat klase ng engineering po. So let's start off with Carnot cycle po. Hindi na po natin to patatagalin pa. Okay? So Carnot cycle po, it represents the highest or the maximum efficiency any heat engine can achieve. Okay? So for you to easily remember Carnot cycle, I would say parang ang tawag sa pinaka definition for it is which cycle has the most efficient cycle. Okay? Which thermodynamic cycle has the most efficient cycle? That is what we call Carnot cycle. Okay? With the cycle with the highest efficiency. Okay? Oops, for a while. So, with the highest efficiency. Okay, so that is Carnot cycle. Okay, so thermodynamic cycles in general, okay, in order for you guys to understand easily or easier the cycle, okay, we have here the PV diagram and TS diagram. Okay, so in order for you to easily understand the different process under Carnot cycle, we have this PV diagram and TS diagram. Again, PV diagram is pressure volume diagram. So, ibig sabihin that is pressure versus volume. And then TS is temperature and entropy diagram. Okay po, nagkakaintindihan tayo doon. So, I do hope you can still recall, okay, the following terms. Okay, so for our diagram. Alright, so first one, okay, so we have here, by the way, yung nasa libro natin about Carnot cycle, it is the same diagram lang din naman po. Yung PV diagram nga lang yung nasa libro natin. Pero nagkaiba lang sa state points. Yung sa libro kasi, dito nagsimula yung 1, then ito 2, and then 3, and then 4. Okay po. So, in our case po, hindi na po yun ang ating susundin, which is ito po ang ating susundin. Itong nandito pong drawing po. Okay po tayo. So, in this case po, but again, same lang naman po nangyari doon. Nag-iba lang po ng state points. Actually, yun naman po ay nasa inyo. Okay? Nasa inyo naman po yun. Okay po tayo doon. Alright. Nasa inyo naman po yun kung alin ang inyong susundin or magiging state points po natin. Okay? Kasi ang paglalagay naman po ng state points ay wala naman pong problema. Okay? Yan naman po yung nasa inyo. Pero, syempre, dapat po yun isunod-sunod na 1. Kung dito ka magsisimula, 2, 3, 4. Okay? Huwag pong basta tayo maglalagay na 1, 2, 3, 4. That is incorrect. Okay? So, ang flow po for auto cycle is clockwise. Okay? Clockwise. Yan. Clockwise po ang rotation ng ating diagram. Ng cycle, rather. Okay? So, Carnot cycle, yan, it's the most efficient or has the highest efficiency or the most efficient thermodynamic cycles. Okay po. So, in this case po, alright, yan. So, we have here, ito yung nagkabaliktad lang. Nagkaroon lang ako dito ng error. Makikikorek na lang po ako nito ha. This must be 1 to 4. 1 to 2 rather. This must be 2 to 1. Ay, sorry. 2 to 3 rather. And then 3 to 4. And then 4 to 1. Tama kasi 4 to 1 compression process. Tama. Yan. Pakorek lang po ako niyan. Okay? And so, okay. So, let's read po the following. Wait lang, tama ba? Reversible isothermal heat addition. So, dito. Hindi, tama pala yun. Sorry. Tama po pala. 4 to 1 nga. Tama. Okay. Alright. So, yan. Pagsabayin na po natin yung discussion ng diagram at saka itong processes in the Carnot cycle po. Okay? So, this one po, okay? So, dito po sa ating diagram, sabi dyan, there are 4 processes in Carnot cycle. So, the first one po is the process under state point 4 to 1. So, ito po yun. Yan. And we call this cycle dito sa PV diagram. By the way, yan yung sa PV diagram. And then, yun naman pong sa TS diagram ay ito. Yan yung ina-analyze natin ha. So, in this part po, okay, yan. In this part po, yan, we call this process reversible isothermal heat addition. Reversible isothermal heat addition. Okay? Isothermal meaning temperature is constant. Okay? And there is this present of heat addition. Okay? Which is ito po. Ito. Yan. So, ibig sabihin po, in that case po, yan. The temperature po is constant. In that case po, T4 is equal to T1. Okay? Nagkakaintindihan po tayo doon. T4 is equal to T1. Okay? And then, second naman, analyze natin is this 1 and 2. Okay? State point 1 and 2. State point 1 and 2. Okay? Sabi dyan na state point 1 to 2 or process from point 1 to 2 is what we call the reversible adiabatic expansion process. Okay? When we say adiabatic, okay, adiabatic, there is no heat transfer. Okay? Ibig sabihin, Q is 0. Okay? Saan nga ba nagsisiro ang heat? Kapag ang entropy ay constant po. Okay? When entropy is constant, ibig sabihin there is no heat transfer, meaning Q or heat is equal to 0. Okay? Nagkakaintindihan tayo doon? Right. And then, for process 2 to 3, okay? 2 to 3. And process 2 to 3. Okay? For process 2 to 3 naman, we call this reversible isothermal heat release process. Isothermal heat release. Okay? That is simply isothermal again is T is equal to C kasi temperature natin is constant, and then heat release, we can say this heat rejected. Okay? Ano po? In that case po, alright? So, heat release po, ang ating ibig sabihin yan, temperature 2 natin is simply equal to temperature 3. O by the way, dito sa process 1 to 2, ang atin pong entropy 1 is equal to entropy 2. Okay po. And then, we have here itong process 3 to 4. And process 3 to 4. Okay? So, for process 3 to 4 naman po, alright? So, we call this process reversible adiabatic compression process. Adiabatic compression process. Again, kapag adiabatic, heat is equal to 0. Ibig sabihin, entropy is constant. Okay? So, in this case po, S3, okay, is simply equal to S4. Okay, so that is the PV diagram and TS diagram of our of our Carnot cycle. By the way, okay, so work can also be obtained through using in cycles. Okay po, ang work po ay nako-compute natin dito. So wala lang sa diagram, but I will tell you kung saan po napasok at nalabas yung work or paano natin mako-compute si work at work dito sa Carnot cycle. So, ang work po can be obtained dito po sa process 3 to 4. Okay? Process 3 to 4. So, makikilagay na lang po ako, makikidagdag sa inyong drawing. Ayan. That is the work done on the system. That is work in or ano ba? Yeah, work in. And then there's also here sa process 1 to 2, work done by naman ito, or yung work output. Okay, so dito naman sa TS diagram, ilalagay natin si work in dito, same dito, 3 to 4, at saka dito. Alright, nagkakaintindihan tayo doon? Okay, so that is for the diagram and processes as well as its processes under Carnot cycle. Okay, so here are its relevant formulas that are related to Carnot cycle or the used formulas for Carnot cycles. Okay, so we have here heat added, meron din tayong heat rejected, meron din tayo ditong for work, meron din tayo for entropy, we have here cycle efficiency, we also have here mean effective pressure. Okay? So, pakita ko lang sa inyo kahit itong heat added kung paano po nangyari yan. Okay? Para makita nyo lang yung derivation. Pero hindi naman kayo dito pagde-derive. Gusto ko lang pakita sa inyo. Okay? So, for heat added, okay? So, from the equation ng entropy, okay? delta Q over T. So, dyan po yan ang galing. And then, since heat ang pinapahanap, delta Q is equal to T times delta S. Okay? So, for process 4 to 1, okay, heat, that is heat added to be specific. Therefore, ang temperature natin doon ay it's either T4 or T1 dahil equal lang naman sila. Okay? And then yung, ito pala ay integral. So, therefore, ito ay magiging integral. Then, so, mangyayari dyan ay Q na lang, T. Then, delta. Ito po pala. Ay, sorry. Delta Q, that would come T D S. Since ito ay from 4 to 1, edi from 4 to 1. Okay, that will give us T is from 4 to 1. Po, in that case po, we have S1 minus S4. Okay, so which is also again, since T1 nga po equal and dependent T4. And then yung S1 natin, since same lang sa S2. And then yung S4 natin, same lang sa S3. So, dyan po yun ang galing. Gusto ko lang ipakita sa inyo itong equation na ito. Okay, doon lang po yun ang galing. Alright? So for you to easily understand these formulas, let's use these equations in problem solving. Okay? So, for sample problems, we have here the sample problem number 1. Okay? So, for sample problem number 1, we have here an industrial refrigeration system operates between two temperature reservoirs. We have here the cold reservoir at Tc is equal to -5 degrees Celsius and the hot reservoir at Th is equal to 50 degrees Celsius. Calculate the maximum possible efficiency of the system. Okay? So, let's solve this problem number 1. So, first thing first, you state the given po. Okay? We have here Tc na -5 degrees Celsius, or we can call this as low temperature. TL is equal to -5 degrees Celsius. And then we have here T hot. Okay? T hot, or pwede rin natin siyang, since ang hot naman po ay high temperature, we call it also TH or high temperature po. Okay? Which is equal to 50 degrees Celsius. Okay? Sabi dyan, find the maximum possible efficiency. Yan. So, for solution, tama? Yun lang? Okay, tama. Solution. Alright? Solution. Ang solution natin dyan for efficiency, okay, for efficiency. Alright. So, first, efficiency symbol, so wala pong problema sa akin kung ganito or ganito yung symbol. Okay? Yan. Pero for uniformity, what we're going to use is ito po. Okay? Yan na po ang ating gamitin for efficiency. So, going back doon sa mga formulas to be used dito sa ating for efficiency, we have here the following equations. Okay? Since madami ito, okay, pwede natin tingnan kung alin doon ang pasok siya. Okay? So, in this case po, ang cycle efficiency can be obtained since meron tayong given na low temperature at saka high temperature, pwede natin tong gamitin. Okay po? This 1 minus TL over TH. By the way, share ko lang for dito, yung T1 po natin, okay, Ang T1 natin is the high temperature. Okay, tandaan niyo yan ha. That is the high temperature. Based dito sa diagram, okay, T4 is equal to T1. Okay? And T4 is the highest temperature sa process po ng Carnot cycle, which is T4 po is just simply equal to T1. Therefore, si T2 is the lowest temperature. Okay? In that case po, T2 is the lowest temperature, which is again simply equal to T3. Okay? So that is TH minus TL over TH po. Okay, so same lang po yan. Okay, ano? So, in that case po, let's solve po. Yan, for efficiency. So, again, pwede natin gamitin yung 1 minus low temperature over high temperature. Okay, so, ano nga to? Substituting, 1 minus, we have here low temperature natin is negative 5. Plus, so add natin ng 273.15 para maging Kelvin. Then, yung pangalawa, 50 plus 273.15 Kelvin. Canceling this out. Okay, calculate po natin. Okay, pan-calculating, ang lumabas pong sagot ay 0.1701995977 times 100%. Okay? Yan. And then, for our efficiency, we have here 17.01995,977%. Okay? So, therefore, the thermal efficiency is equal to 17.01995,977% po. That is the answer for problem number 1. Okay? Do you have questions po so far? Okay. So, let's proceed muna dito for number 2 rather. Okay? So, a Carnot engine operates between a heat source at 800 Kelvin and a heat sink at 300 Kelvin. If the engine absorbs 1,200 kilojoule of heat from the heat source, calculate A, the thermal efficiency of the engine, B, the work output of the engine. Okay? So, for letter A, So, first thing first, write down the given. Okay? Meron tayo ditong 800 Kelvin, which is the high temperature. Meron tayo ditong 300 Kelvin, which is the low temperature. And then, if the engine absorbs of heat, or 1,200 kilojoule of heat absorbs, that is QA. Okay, or heat added or heat absorption. Yan. So, calculate A, thermal efficiency, and then for B, the work output. Okay? Or the work output. So, solution. For A, efficiency, so basically, meron na tayong T high at saka T low. We're just simply going to use this equation again. Okay? Wherein, or efficiency rather, is equal to 1 minus T low over T high. Whereas, substitute natin ng values. T low natin is 300 Kelvin. So, therefore, no need to add 273.15. That is an absolute value already. Divided by 800 Kelvin. Okay? Dividing this, solving this equation po, this part, will give us 0.625 times 100. Therefore, ang efficiency natin ay 62.5 degrees Celsius. This is for letter A. Did you yield the same answer? Did you yield the same answer po? Right. For letter B naman, work. Okay? Since we are given here an efficiency, meron tayong efficiency, meron din tayo heat heat added. So looking at the equations, ang pinapanap sa atin ay work. Okay? Dito upon checking this, kahit gamitin natin yung equation na yan, wala tayong heat rejected. Okay? Wala din tayong meron tayong T1, meron tayong T2, kaso wala tayong S1 at saka S4. So, X na tong C. And then, syempre dito sa D naman, wala din tayong entropy. Okay? So, technically, hindi din to pwede. So, since meron na tayong cycle efficiency, and then meron tayong heat added, ito, saka ito, therefore, pwede natin gamitin tong cycle efficiency is equal to work over QA. Okay? So, from there, efficiency is equal to work over QA. Okay, so rearranging this equation, we have work is equal to the efficiency times heat added. Okay, so work is equal to the efficiency 0.62625. QA natin as 1,200 kilojoule. Okay? Therefore, ang ating work output is equal to 750 kilojoule. Yan na po. That's how you solve problem number 2. Okay? Do you have question po? Question so far? Alright. So, that is for Carnot cycle po. Okay?